Linear equations. So solving all kinds of equations is truly one of the most important skills one can learn in college algebra. We're gonna start by showing how to solve linear equations. Remember that to solve an equation, we completely isolated the variable until we get or find its value. And isolating the variable involves removing all numbers around the variable until the variable is all by itself. So for example, in this equation that we're about to solve in a minute, we would like to remove all the numbers around the variable, in this case the 3 and the 2, until we get the x standing all by itself. Now, the numbers around the variable are typically removed by carrying out the opposite operation associated to the numbers in the equation. So that's what you have to do. You have to do always the opposite of the operation associated to that number. So for example, in this one, uh, let's start let's start by solving this one. It says 3x plus 2 equals 11. And you have to also remove the numbers in the opposite order as in PEMDAS, as in the order of operation. So normally if I look at this, if I were to plug in a value for x, I would first multiply by 3 and then add 2 to evaluate this. But in the case of solving an equation, you want to do it backwards. You want to get rid of these 2 and then get rid of the 3, not get rid of the 3 and then of the 2, as um, the order of operations would be times 3 first and then plus 2. But we're going backwards because we're going to solve for x. Okay, so let's remove the 2 first. So that would be the first thing we need to remove in this example is the 2. And because the 2 is being added, we have to do the opposite of adding 2, which is subtracting 2. So we have 3x, let me write this again, 3x plus 2 equals 11. I would like to get rid of this plus 2, so I do the opposite of adding 2, which is subtract 2. And whatever you do to one side of the equation, you have to do it to the other side to keep things balanced. So you would write minus 2 on the other side as well. So some people write the minus 2 like this horizontally, and then they will uh, cross this out and say, okay, two, these two cancel each other because 2 minus 2 is 0. And then you're left with 3x equals, and then 11 minus 2 is 9. So that's one way to write that down. Some other people write this vertically instead of horizontally like that. So some people would write this like this. So let's say 3x plus 2 equals 11. So I'm writing that again. Some people would just write the minus 2 down, like vertically like this. And then say, okay, now add down this. Now these cancel. You would get 3x equals 11 minus 2, which is 9. So it's really just a matter of preference. You could write it either way. I normally write it horizontally, more like this. However, I don't write this part over there, so I just basically write the 3x. I would normally write the 3x equals 11 minus 2. And I like saying that, um, for visual purposes, I like saying that the 2 moved to the other side, and so it's like you throw it over the fence. So I imagine like the equal sign is like a fence. So I like saying that you throw the 2 over the fence to the other side, and when you throw it over the fence, it changes sign. It changes the operation. So if it was a plus 2, um, it would become a minus 2. So typically, the way I write this, and that's just my thing, I would do this. So I would say move the 2 to the other side, and you would get 11 minus 2. So that's how we normally would write that. But you could write it any way you want to. It doesn't matter. Normally, this is the way I'm gonna write it though. So in this equation right here, now let's write that first step. I would say, okay, move this to the other side. And when you move it to the other side, you're going to get 3x equals 11 minus 2. Okay, now 3x equals 9, because 11 minus 2 is 9. And then lastly, you divide both sides by 3 because you multiply. This x has been multiplied by 3, and you want to do the opposite of multiplying by 3. The opposite of multiplying by 3 is dividing by 3. So you divide by 3 both sides, and now you can say these 3 cancel, and then you end up with x equals 9 divided by 3, which is 3. Okay, and that's the answer for that one. And that basically contains the whole idea of how to solve a linear equation. You could get a little bit more complicated if you have like fractions or parentheses and things like that. And we'll do some examples like that, but that's basically it. Whether it might require more steps, but that's it. All right, let's do another one. Let's try to do this one. This one has a parenthesis in there. And what we want to do is, you see the x is like trapped inside that parenthesis. We really need to get it out of there. And in order to get it out of there, we need to distribute first thing. So then this is going to become 9x minus 13 equals 6x distributed plus 2. Okay, so first thing was distribute. Now, I want all the x's on one side and everything that doesn't have an x on the other side. So, I would like this 6x to move to this side, and I would like this minus 13 to move to the other side. So remember the way I said it, we just gonna basically like throw it over the fence. When you do that, the signs do change. So then you're gonna have on the left hand side 9x minus 6x, because right now the 6x on the right hand side is positive, so it moves as negative. And then the minus 13, when you throw it to the other side, it becomes plus 13. All right, and now you simplify. 9x minus 6x is 3x. And then 2 plus 13 is 15. And now divide by 3. Again, it's going to cancel. And then you're going to end up with x equals 15 over 3, which is 5. 15 divided by 3 is 5. And that's that. You see that this will require a couple more steps because we needed to distribute to get the x out of that parentheses. And we had here in this example, x is on both sides of the equation, and you need to move all the x's to the same side to group them and then isolate it. All right, here this one has many more parentheses, but it's still the same. So let's tackle this one. Okay, you need to get the x's out of all those parentheses. So let's distribute. So we're going to distribute that. We're going to distribute that. And this minus also has to be distributed. Okay, that minus also has to be distributed. So we're going to get 6x minus 30. And then when you distribute this minus, this is going to be negative 2x plus 4. And then on the right hand side, this is going to be 2x plus 4. Okay. Now, let's combine simplify the left-hand side a little bit before we move things around. So combining these x's, 6x minus 2x, that's 4x, and then negative 30 and positive 4, that's negative 26, equals 2x plus 4. So I just simplify a little bit the left-hand side by combining like terms, whatever I could combine, the x's and the constants. All right, now we are ready to move things around. I want all the x's on the same side, so let's move this to this side and that to the other side. Okay, so when we do that, we're gonna get 4x minus 2x on the left, and on the right, 4 plus 26. Okay, and then 4x minus 2x is 2x, and 4 plus 26 is 30. And then divided by 2, we're going to get our answer. So dividing by 2, we're going to get that x equals 30 divided by 2, which is 15. Okay, and here is another one. This one has fractions. And even though it is solved the exactly same way as the ones we've solved above, I'm going to tell you the trick for how to do this easily when you have fractions involved. Okay, and this is going to be important because this is also the way when you have rational expressions, how you solve equations that have rational expressions involved. Okay, so the easiest way of solving this when you have fractions involved in the equation is to get rid of all the fractions by multiplying by the LCD, by the least common denominator. So the LCD, in this case, the least common denominator of all the fractions that you see is 12, right? Because the denominators that you see are 3 and 4. The least common denominator is going to be 12. So the LCD is going to be 12. So that means we're going to multiply the entire equation, every single term, by 12. And the idea is that when you do that, you're going to get rid of all the fractions. All the fractions are going to disappear at once. And you will not have any more fractions. So it will be just a problem like the ones above, where it's all whole numbers. We won't have fractions anymore. All right, so let's do that. Everything is going to get multiplied by 12. So this 1/3 times x minus 12 that I have on the left is going to get multiplied by 12. And then this 1/4 x minus 4 that I have here is going to get multiplied by 12. And then this minus 1, right, that one, is going to get multiplied by 12. Every term in the equation is going to get multiplied by 12. Every term. Okay, then when you simplify, you're not going to have fractions anymore. So canceling a 3 from here, you're going to get a 4. Canceling this 4 from here, for 12 divided by 4, you're going to get 3. And that's it. So what are you left with? You're left with 4 x minus 12 equals, then you have this 3 x minus 4, and then 1 times 12 is 12. And now you see you have an equation that is just like the ones above. Everything is a whole number, and it should be easy to solve. So that is the trick. Get rid of all, if you see fractions, get rid of all the fractions right away by multiplying everything by the LCD. All right, now let's proceed as above. So now distribute this. So this is 4x minus 48. 4 times 12 is 48. And then distribute in here, this is 3x minus 12. minus 12. So then, um, this is going to be 4x minus 48, and then simplifying this side a little bit, that's 3x minus 24. Negative 12 and negative 12 is negative 24. And then moving things around, I'm going to move this 3x to the left. That moves us negative 3x or minus 3x. And then move the 48. So it will be negative 48. It will be negative 24 plus 48. Now 4x minus 3x is just x. And then negative 24 plus 48 is positive 24. And that is the end. So you see, we did not even though there were fractions involved at the beginning, we did not even have to get our hands dirty with any fractions at all because we got rid of them. We got rid of all the fractions on the very first step.